Unit 3. Describing and Interpreting Test Scores. 3.1. Introduction. In Unit 2 learned about various assessment strategies that can be used in the context of secondary education. You were also introduced with the planning, construction, and administration of classroom tests. In this unit you are going to be familiarized with the idea of test score interpretation and the major statistical techniques that can be used to interpret test scores. Particularly, you will learn about the methods of interpreting test scores, measures of central tendency, measures of dispersion or variability, measures of relative position, and measures of relationship or association. Learning outcomes. Upon completion of this unit, you should be able to describe test scores, list techniques of interpreting scores, apply measures of central tendency, variability, relative position and relationship in interpreting scores. Select appropriate techniques for interpreting test scores. Develop reports on the implications of scores. Propose appropriate score interpretation-based decisions. 3.2. Describing and interpreting test results. Imagine that you receive a grade of 60 for a midterm exam in one of your university classes. What does this score mean, and how should we interpret it? Test interpretation is a process of assigning meaning and usefulness to the scores obtained from classroom test. This is necessary because the score obtained from a test standing on itself rarely has meaning. For instance, a score of 60% in one assessment and evaluation of learning test cannot be said to be better than a score of 50% obtained by the same test taker in another test of the same subject. The test scores on their own lack a true 0 point and equal units. Moreover, they are not based on the same standard of measurement, and as such meaning cannot be read into the scores on the basis of which academic and psychological decisions may be taken. Kinds of scores. Data differ in terms of what properties of the real number series order, distance, or origin we can attribute to the scores. The most common kinds of scores include nominal, ordinal, interval, and ratio scales. A nominal scale involves the assignment of different numerals to categorize that are qualitatively different. For example, we may assign the numeral 1 for males and 2 for females. These symbols do not have any of the three characteristics order, distance, or origin we attribute to the real number series. The 1 does not indicate more of something than the 0. An ordinal scale has the order property of real number series and gives an indication of rank order. For example, ranking students based on their performance on a certain athletic event would involve an ordinal scale. We know who is best, second best, third best, etc., but the rank do not tell us anything about the difference between the scores. With interval data, we can interpret the distances between scores. If, on a test with interval data, a Ralmas has a score of 60, a Biba score of 50, and Bishadu a score of 30, we could say that the distance between Abib's and Bishadu's scores 50 to 30 is twice the distance between Elma's and Abib's scores 60 to 50. If one measures with a ratio scale, the ratio of the scores has meaning. Thus, A person whose height is 2 meters is twice as tall as a person whose height is 1 meter. We can make this statement because a measurement of 0 actually indicates no height. That is, there is a meaningful 0 point. However, if a student scored 0 on a spelling test, we would not interpret the score to mean that the student had no spelling ability. 3.2.1 Methods of interpreting test scores. If a student responds correctly to 65 items on objective tests which each correct item counts 1 point, the raw score will be 65. This raw score is simply the number of points received on a test when the test has been scored according to the directions. We all are familiar with raw scores from our many years of taking classroom tests. Although a raw score is a numerical summary of a student's test performance, it is not meaningful without further information. In general, we can provide meaning to a raw score either by converting it into a description of the specific tasks the student can perform, criterion-referenced interpretation, or converting it into some type of derived score that indicates the student's relative position in a clearly defined referenced group, norm-referenced interpretation. In some cases, both types of interpretation may be appropriate and useful. Criterion-referenced interpretation. Criterion-referenced interpretation is the interpretation of test raw score based on the conversion of the raw score into a description of the specific tasks that the learner can perform. That is, a score is given meaning by comparing it with the standard of performance that is set before the test is given. It permits the description of a learner's test performance without referring to the performance of others. Thus, we might describe a pupil's performance in terms of the speed with which a task is performed, the precision with which a task is performed, or the percentage of items correct on some clearly defined set of learning tasks. The percentage correct score is widely used in criterion-referenced test interpretation. Criterion-referenced interpretation of test results is most meaningful when the test has been specifically designed for this purpose. This typically involves designing a test that measures a set of clearly stated learning tasks. Enough items are used for each interpretation to make it possible to describe test performance in terms of students' mastery or non-mastery of learning tasks. Norm-referenced test interpretation. Norm-referenced interpretation is the interpretation of raw score based on the conversion of the raw score into some type of derived score that indicates the learner's relative position in a clearly defined referenced group. This type of interpretation tells us how an individual compares with other persons who have taken the same test. Norm-referenced interpretation is usually used in the classroom test interpretation by ranking the test takers' raw scores from highest to lowest scores. It is then interpreted by noting the position of an individual's score relative to that of other test takers in the classroom test. The interpretation, such as third position from highest position, or about average position in the class, provides a meaningful report for the teacher and the test takers on which to base decision. In this type of test score interpretation, what is important is a sufficient spread of test scores to provide reliable ranking. The percentage score, or the relative easy/difficult nature of the test, is not necessarily important in the interpretation of test scores in terms of relative performance. 3.2.2 Measures of central tendency. It is often important to summarize characteristics of a distribution of test scores. One characteristic of particular interest is a measure of central tendency. The goal of the measures of central tendency is to come up with the one single score that best describes a distribution of scores. They let us know if the distribution of scores tends to be composed of high scores or low scores. There are three basic measures of central tendency: the mean, the mode and the median, and choosing one over another depends on two different things. 1. The scale of measurement used, so that a summary makes sense given the nature of the scores. 2. The shape of the frequency distribution, so that the measure accurately summarizes the distribution. The mean, or arithmetic average, is the most widely used measure of central tendency. It is the average of a set of scores computed simply by adding together all scores and dividing by the number of scores. The mean takes into account the value of each score, and so one extremely high or low score could have a considerable effect on it. It is helpful to know the mean, because then you can see which numbers are above and below the mean. The median. In some circumstances, the mean may not be the best indicator of student performance. If there are one or a few students who score considerably lower or higher than the other students, their scores tend to pull the mean in their direction. In this case, the median is usually considered a better indicator of student performance. There are also some types of scores that are reported for standardized tests for which the mean is not appropriate: percentile scores. So the median is used. The median is a counting average. It is the number that divides a distribution of scores exactly in half. It is determined by arranging the scores in order of size and counting up to or down to the midpoint of the set scores. The median will usually be around where most scores fall. When the number of scores is odd, the median is the middle score. If the number of scores is even, the median will be halfway between the two middlemost scores. In this case, the median is not an actual score earned by one of the students. The mode. This is the score or scores that occur most frequently and is determined by inspection. It is the least reliable type of statistical average and is frequently used merely as a preliminary estimate of central tendency. A set of scores may sometimes have two or more modes, and in such cases are called bimodal or multimodal respectively. If the data is categorical measured on the nominal scale, then only the mode can be calculated. The mode can also be calculated with ordinal and higher data, but it often is not appropriate. If other measures can be calculated, the mode would never be the first choice. Shape of distributions. Skewness. There is one important situation in which all three measures of central tendency are identical. This occurs when a distribution is symmetrical, that is, when the right half of the distribution is the mirror image of the left half of the distribution. In this case, the mean will fall exactly at the middle of the distribution, the median position, and the value at this central point will be the most frequently observed data value, the mode. If the values of the mean, the mode and the median are identical, a distribution will always be symmetrical. To the extent that differences are observed among these three measures, the distribution is asymmetrical or skewed. These include positively skewed distributions and negatively skewed distributions. In a positively skewed distribution, most of the scores concentrate at the low end of the distribution. This might occur, for example, if the test was extremely difficult for the students. In a negatively skewed distribution, as shown in Figure 1 above, the majority of scores are toward the high end of the distribution. This could occur if we gave a test that was easy for most of the students. Points to note: with perfectly bell-shaped distributions, the mean, median, and mode are identical. With positively skewed data, the mode is lowest, followed by the median and mean. With negatively skewed data, the mean is lowest, followed by the median and mode. 3.2.3 Measures of variability or dispersion. The measures of central tendency focus on what is typical, average, or in the middle of a distribution. The information provided by these measures is not sufficient to convey all we need to know about a distribution. Knowing the mean, the median, or the mode, or all of these of a distribution does not allow us to differentiate between distributions. We need additional information about the distributions. A set of scores can be more adequately described if we know how much they spread out above and below the measure of central tendency. For example, we might have two groups of students with a mean score of 70, but in one group the span of scores is from 60 to 80, and in the other group the span is from 50 to 100. These represent quite different spreads of performance. We can identify such differences by numbers that indicate how much scores spread out in a group. These are called measures of variability or dispersion. The three most commonly used measures of variability are the range, the quartile deviation, and the standard deviation. The range, it is the simplest and crudest measure of variability calculated by subtracting the lowest score from the highest score. For example, if the score of 10 students in a certain test is 5, 7, 8, 10, 12, 13, 14, 15, 17, 19, then the range will be 19 minus 5 is equals to 14. The range provides a quick estimate of variability, but is undependable because it is based on the position of the two extreme scores. The addition or subtraction of a single score can change the range significantly. Interquartile range is another range measure, but this time looks at the data in terms of quarters or percentiles. Is the distance between the 25th and 75th percentile or the first and third quarter. The range of data is divided into 4 equal percentiles or quarters. 25% is the range of the middle 50% of the data. Therefore, because it uses the middle 50%, it is not affected by outliers or extreme values. The ICR is often used with skewed data as it is insensitive to the extreme scores. The standard deviation, let us say that 2 classes took a quiz. There were 10 students in each class, and each class had an average score of 81.5. Since the averages are the same, can we assume that the students in both classes have the same performance on the exam? The answer is no. The average mean does not tell us anything about the distribution or variation in the grades. So, we need to come up with some way of measuring not just the average, but also the spread of the distribution of our data. The most useful measure of variability, or spread of scores, is the standard deviation. It is essentially an average of the degree to which a set of scores deviates from the mean. If the standard deviation is large, it means the numbers are spread out from their mean. If the standard deviation is small, it means the numbers are close to their mean. Because it takes into account the amount that each score deviates from the mean, it is a more stable measure of variability than either the range or quartile deviation. The procedure for calculating a standard deviation involves the following steps. 1. Compute the mean. 2. Subtract the mean from each individual score. 3. Square each of these individual scores. 4. Find the sum of the squared scores. 5. Divide the sum obtained in step 4 by n, the number of students, to get the variance. 6. Find the square root of the result of step 5. This number is the standard deviation SD of the scores. Variance is the average squared deviation from the mean of a set of data. It is used to find the standard deviation. Finally, we calculate the square root of the variance. This will give us standard deviation. Which measure of dispersion to use? The quartile deviation is used with the median and is satisfactory for analyzing a small number of scores. Because these scores are obtained by counting, and thus are not affected by the value of each score, they are especially useful when one or more scores deviate markedly from the others in the set. The standard deviation is used with the mean. It is the most reliable measure of variability and is especially useful in testing. In addition to describing the spread of scores in a group, it serves as a basis for computing standard scores, the standard error of measurement, and other statistics used in analyzing and interpreting test scores. 3.2.4 Measures of relative position. There are different ways to measure the relative position of scores. Suppose that you have scored 55 on a test. What do you say about this score? On the surface it might look bad, but what if that was the highest in the class, or if that score was better than 80% of the class? This is what we mean by relative position. Percentiles. A percentile is a score that indicates the rank of the student compared to others same age or same grade. Using a hypothetical group of 100 students, it tells you what percentage of people you did better than. A percentile of 25, 25th percentile, for example, indicates that the student's test performance equals or exceeds 25 out of 100 students on the same measure. A percentile of 87 indicates that the student equals or surpasses 87 out of 100, or 87% of students. A percentile must always refer to a student's percentile rank as relative to a particular norm group. If you scored at the 80th percentile, what does that mean? Converting data value to percentile. 1. Arrange the data in ascending order. 2. Count how many items are below your value. If, for example, your score is 85, and there are multiple 85s, then count how many are under the first 85. For example, in the student's scores of 76, 77, 80, 83, 85, 85, 85, 90, 96, 97, there are 4 items below 85. Quartiles. Quartile is another term referred to in percentile measure. The total of 100% is broken into 4 equal parts: 25%, 50%, 75%, 100%. Lower quartile is the 25th percentile, 0.25. Median quartile is the 50th percentile, 0.50. Upper quartile is the 75th percentile, 0.75. Standard scores. Another method of indicating a pupil's relative position in a group is by showing how far the raw score is above or below average. This is the approach used with standard scores. Basically, standard scores express test performance in terms of standard deviation units from the mean. Standard scores are scores that are based on mean and standard deviation. Types of standard scores. Z-score, for data distributions that are approximately symmetric, a measure of relative position that is often used as the Z-score. Z-score gives us an estimate as to how many standard deviations a particular score lies from the mean. For instance, if a person scored a 70 on a test with a mean of 50 and a standard deviation of 10, then they scored 2 standard deviations above the mean. So, a Z-score of 2 means the original score was 2 standard deviations above the mean. If the Z-score is 0, then your data value is the mean. If the Z-score is 0 positive, then your data value is above the mean. If the Z-score is 0 negative, then your data value is below the mean. T-scores. This refers to any set of normally distributed standard scores that has a mean score of 50 and a standard deviation of 10. The T-score is obtained by multiplying the Z-score by 10 and adding the product of 50. That is, T-score equals 50 plus 10Z. A score of 60 is 1 standard deviation above the mean, while a score of 30 is 2 standard deviations below the mean. 3.2.5. Measures of relationship. If we have 2 sets of scores from the same group of people, it is often desirable to know the degree to which the scores are related. For example, we may be interested in the relationship between the test scores of students for the English subject and their overall scores of other subjects. The degree of relationship is expressed in terms of coefficient of correlation. The value ranges from minus 1.00 to plus 1.00. A perfect positive correlation is indicated by a coefficient of plus 1.00 and a perfect negative correlation by a coefficient of minus 1.00. A correlation of 0.00 indicates no relationship between the 2 sets of scores. Obviously, the larger the coefficient positive of negative, the higher the degree of relationship expressed. There are several different measures of relationship expressed as correlation coefficients. One of these is the product moment correlation coefficient, which is by far the most commonly used and most useful correlation coefficient. It is indicated by the symbol A. Project work. in groups of 5. Take the roster of one cooperating teacher of the school you are placed for your practicum experience, and do the following tasks: calculate the average marks of the students of the section by taking 5 subjects based on the calculated averages. Find the mode, the median, the range, the interquartile range, and the standard deviation. Find the average scores that lie in the 25th, 50th, and 75th percentiles. Take the scores of 2 subjects and calculate the coefficient of correlation. You have to prepare a report of your work and submit it for correction. 3.3 Characteristics of a good test. Test, as an instrument, possesses some qualities which are necessary before it can be eligible as a test and usable. A test should therefore possess the following characteristics. Validity is the most important quality you have to consider when constructing or selecting a test. It refers to when a test serves its purpose, that is, measures what it intended to measure, and to the extent desired. It is concerned with whether the information being gathered is relevant to the decision that needs to be made. It is all about the extent to which assessment information can be trusted. Truthfulness. Thus, validity is always concerned with the specific use of the results and the soundness of our proposed interpretations. Hence, to the extent that a test score is decided by factors or abilities other than that which the test was designed or used to measure, its validity is impaired. The following factors can influence the validity of a test: unclear direction, inappropriate level of difficulty, poorly constructed items, clues to items, test item inappropriate for the objectives being measured, improper arrangement of item, identifiable pattern of answers, cheating in exams, emotional disturbance of examiners. Reliability. Test reliability refers to the accuracy, consistency and stability of scores students would receive on alternate forms of the same test. The more the pair of scores observed for the same test varies from each other, the less reliable the measure is. The more consistent our test results are from one measurement to another, the less error there will be, and consequently, the greater the reliability. Reliability is a precursor to test validity. If test scores cannot be assigned reliably, it is impossible to conclude that the scores accurately measure the domain of interest. There are some factors the reliability of a test which include the following. Test length. The longer a test is, the more reliable it is in that wide coverage of content is ensured, but not too long. Sample heterogeneity. The more heterogeneous the test items, the higher the reliability. Irregularities. Lightning conditions. Test is failure to follow directions. In order to be valid, a test must be reliable, but reliability does not guarantee validity. Objectivity. The fairness of a test to the testee. Bias test does not portray objectivity and hence is not reliable. A test that is objective has high validity and reliability. Discrimination. A good test must be able to make distinction between poor and good learner. It should show the slight differences between learner attainment and achievement that will make it possible to distinguish between poor and good learner. What are the likely criteria in order to satisfy these conditions? Comprehensiveness. Test items that covers much of the content of the course. that is, the subject matter is said to be comprehensive, and hence capable of fulfilling purpose. Ease of administration. A good test should not pose difficulties in administration. Practicality in scoring. Assigning quantitative value to a test result should not be difficult. Why, what, and how? Usability. A good test should be usable, unambiguous and clearly stated with one meaning only. Unit summary. In this unit you learn that test interpretation is a process of assigning meaning and usefulness to the scores obtained from classroom test, and you were introduced to how to interpret test scores. This includes criterion-referenced and norm-referenced interpretation. Criterion-referenced interpretation is the interpretation of test raw score based on the conversion of the raw score into a description of the specific tasks that the learner can perform. Norm-referenced interpretation is the interpretation of raw score based on the conversion of the raw score into some type of derived score that indicates the learner's relative position in a clearly defined reference group. This unit also introduced you with different statistical techniques that are useful in interpreting test scores. These are classified into measures of central tendency, measures of dispersion, measures of relative position, and measures of association or relationship. The measures of central tendency help us to come up with the one single score that best describes a distribution of scores. The most commonly used measures of central tendency are the mean, the mode, and the median. The measures of dispersion tell us how much the scores spread out above and below the measure of central tendency, as well as how much they are spread out from one another. These measures include the range, the interquartile range, and the standard deviation. The measures of relative position are techniques that will show us the relative standing of individual scores within a certain set of scores. Measures that are used here include percentile ranks, quartiles, and standardized scores such as the Z-scores and T-scores. The measures of relationship or association help us to know the degree to which sets of scores are related. The most commonly used measure of relationship is the product moment correlation coefficient. Finally, you have also learned about the major characteristics that make a good test. Self-check exercises. 1. What is test interpretation, and why is it necessary to interpret classroom tests? 2. Highlight the major difference between criterion-referenced interpretation and norm-referenced interpretation of test scores. 3. Suppose a student has taken 2 quizzes in a statistics course. On the first quiz the mean score was 32, the standard deviation was 8, and the student received a 44. The student obtained a 28 on the second quiz, for which the mean was 23, and the standard deviation was 3. If test scores are approximately normal, on which quiz did the student perform better relative to the rest of the class? 4. You have given an exam to your students. Scores on this exam are normally distributed with mean equals 40 and standard deviation equals 6. A. What score would a student need to be in the top 15%? B. What score represents the 45th percentile? C. If 200 students took the exam, how many would you expect to score below 30?